What's up, guys? Let's start chapter 1.2 of Math 108. We're going to look at graphs of functions. So we've got this graph y equals x squared that we're looking at on your lecture notes, and we want to graph it. It's a pretty simple process. Okay, so typically what we're going to do, let's add some notes here. So typically what we're going to do is we're just going to pick some x's to start with, and we're going to pick some y's to start with, and we're just going to kind of go from there. So if I pick x to be, say, -2, -1, 0, 1, 2, 3. If we go with the easy ones, 0 squared is just 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Okay. Now, if we're looking at -1 squared, still going to be 1. -2 squared, still going to be 4. Right? Easy enough. Okay, all I'm doing is plugging -2 in for x in this equation up top. Okay, so easy enough. You should be able to do this. Your calculator can do it for you. If you really want to be that lazy, that's cool. Now, let's go about graphing it. So, if I go over here to -2, and then I want to go up 4. 1, 2, 3, 4. I'm going to put me a dot right there. Now I'm going to go to -1, and I'm going to go up 1, and I'm going to put me a dot right there. I'm going to put me a dot at 0, 0. And if you'll notice, it kind of winds up being a mirror image on the other side. And that's kind of how the squared function works. Now we didn't plot a -3 here, so we don't have a corresponding point for that. But if the graph would have continued in that direction, we sure enough would have had a corresponding spot up here at -3, 9. So that what you get when you graph it, and I'll do as best I can, is a function that looks somewhat like this. That should be pretty simple and straightforward. Obviously not perfect, but it's hand drawn. If you come over here to your TI calculator, you really wanted to graph it and be lazy, you could just type in x squared. You could graph it on a standard viewing window. You see it's about the same thing we've got. You could hit second table, and it gives you all the values that you're interested in seeing. So we've got the 0, 0, the -1, 1, the 2, -2, 4, the -3, 9. We've got +1, 1, +2, +4, 3, 9, and so on and so forth. Pretty easy, pretty straightforward thing to do. Alright, so if we scroll on down and continue on with the notes, the goal really here is to get a complete graph. So a lot of the times this is where the TI 81 or 89 or whatever you're using in this class, 84, it's where it comes in and helps you out. So a lot of times we can pick some numbers, but if we do so randomly, if I'd have randomly only chose 1, 2, 3, 4, 5, 6, 7, 8, 9, I'd have never known that this graph dipped down and came back up. The advantage of the TI is that you can come over here, and a lot of times you can get a really good picture of the graph instead of having to guess some random numbers and then try to put it together by hand. One of the things that you have to worry about when doing this is window size, and how to get it to really fit. Now we've kind of showed you the table function. That's where you can hit second graph or second blue table, and it gives you this table function of values here. Another thing that you can also do to find more values or points on the graph is you can hit that trace button. You don't need to do second trace, just hit trace. And what it does is it traces the line and it gives you a whole bunch of points. Most of them are decimals here. Occasionally you will get a whole number. The reason why the second table I think is a little more helpful is because the second table does give you the actual whole numbers most of the time. At least for the X it does. Sometimes for the Y you'll wind up with a whole bunch of decimals. If you do have to change the window, I always try to change it with zoom first, unless I'm given a window. A lot of times what I'll do is I'll start with standard, which is number 6. I'll go to zoom fit next, if that helps. And if that doesn't help, I usually go to zoom in or zoom out, which are 2 and 3. And I'll kind of work with the function from there. It depends on what function you're doing on really how to do that. Sometimes the instructions will give you a window. If it gives you a window, you can type in your X min, your X max, your Y min, your Y max. You can type all that in. Sometimes the problem will give you that, but sometimes it won't. You just kind of have to play around with your calculator and get used to the functions on it, really. Now, if we scroll on down to page 2, it says the number of U.S. adults with diabetes in thousands projected to 2050 is shown in the table. So we've got this table here. And A says it wants us to align the data so that X equals the number of years after 2015, and enter the X values into L1 of your graphing calculator, and then enter the millions of US adults with diabetes in L2. Okay, so if your X equals the number of years after 2015, that means in 2015, that's year 0. In 2020, it would be year 5. In 2025, it would be year 10. 2030, it would be year 15. And so on and so forth. So that 35 is 20. 40 is 25. 45 is 30. And 50 is 35. Now this is important because, like I said, or like the problem says, we're going to put this into L1 of your graphing calculator. Okay, so if I come over here, first thing I'm going to do is get out to my main screen. Now what it says when it says put it in your L1 of your calculator, how we're going to do that, we're going to hit this stat button here. And then it's going to bring you to this screen, and then you're going to hit edit. And it brings you to L1 and L2. If you already have something in L1, go up to L1, so hit the up button, hit clear, and then hit enter. And it'll clear that whole list out for you. Every now and then I get a student that doesn't have a list 1 or a list 2 because it's been deleted. If that's the case, you have to reset your calculator. That's the only way I really know to get it back. So if you need to, look up the instructions on how to reset your calculator. It's really simple. I'm not going to go over it right this second. If you have trouble with it, let me know. Send me an email. But reset your calculator, you'll get your list 1 and your list 2 back. Now that we have our list 1 back, we obviously started at 0, went up by 5s, so we can type all that in. 0, 5, 10, 15, 20, 25, 30, 35. Oops. Make sure you type it all in right. You can have a typo there. You just fix it. And 40. Now the next thing we have to do is we've got to type the millions in the list 2. So if I pull this up, I can push this to this side. I can pull this to this side so that I can type this in to my list 2. So I'm going to scroll this over so I can see. So now these, if you look at it, sometimes you have to be really careful with these problems. It says enter the number of millions of US adults with diabetes in L2. Okay, well, tricky enough here, the column here is thousands. Okay, so if you got to think about it, there's 37,300 thousandths, which is kind of confusing. Every now and then you'll get a confusing problem where you have to do a little transfer. So if this is truly 1,000, then there's actually 3 more zeros sitting right here that are kind of unaccompanied for because they're in thousands. Now this is just a regular number, if that makes sense. So if I wanted this to be in millions, my decimal place is actually going to be, if I change colors, my decimal place is actually going to wind up being right here, because this is hundreds, this is 100,000s, this is millions. So the number I actually need to type in my calculator for this first one's going to be 37.3. Okay, number for the second one's actually going to be 50. And you kind of get the point. So let's follow that along, and we're going to type this list in on L2. So let me get it back where I could see it. So we've got a 37.3. We've got a 50. We've got a 59.5. We've got a 68.3. A 76.2. An 84.1. A 91.7. And 100. Okay, now I've obviously missed something here. Because my 2 lists don't line up. Ah, I see what my issue was. My first list didn't actually go to 40. Now it's a good thing I've done this, because instead of deleting the whole list, you can really just go down here to the value, hit delete, and it deletes it. So if you didn't see that, remember before I errantly said that there was a 40 here. If you accidentally type something in the list, you don't have to clear your whole list. Just use the delete button to delete it out. Don't use the clear button, use the delete button. Okay, so now that we have these 2 lists typed in, what it wants us to do here, oops, wrong screen. What it wants us to do here is, let's see, use the graphing command to create a scatter plot of these data points. Okay, the way we do that, if we've got our TI pulled up, we've got our data put in L1 and L2. So what we're going to wind up doing here is we're going to need to turn our stat plot on. To do that, we're going to go second y equals. Okay, plot 1 is off. We want to turn plot 1 on. So we hit enter. And now it's flashing on, but I need to hit enter again to get the bold black part actually on the on part. Now, it needs to be on the scatter plot one, which it typically is if you haven't worked with this feature before. Otherwise, it's typically the first one in the list. Okay, your X list needs to be your L1, your Y list needs to be your L2. That should be standard, but if it's not, change it. If everything's set right there, the next thing you do so that you can graph it and see this function, you're going to want to hit the zoom thing. Now, I went over zoom in, zoom out, zoom standard, and zoom fit. Well, when you're graphing scatter plots, the best one to choose is zoom stat. Zoom stat will automatically put it in here for you just like it needs to be. But what you'll see here is when I graphed it, I've got this line that shoots through here. Makes no sense. That line is that leftover x squared. You got to make sure your y1's cleared out. Then your graph looks perfectly fine. All your points are captured when you use zoom stat when you're doing a scatter plot. And there it is. So if you look at it, it's a pretty straight linear line. It might not be perfect, but it's pretty straight. Alright, so we have it, wrong screen. We have it put in. Easy enough to graph the scatter plot. Okay, so the next example here says make a table of values for each function and then plot the points to graph the function by hand. Okay, so we've learned a little bit how to use a scatter plot. We've already graphed one thing by hand. Let's graph this one by hand as well. We'll elaborate on the whole scatter plot thing later, and we'll look at estimating that scatter plot with a linear line, and later on in the semester with different types of curves. But it's just a slow introduction right now to make sure you can use your calculator. Alright, let's go ahead and graph this function by hand. So we've got f of x equals 1/2 x squared. And what we need to do here is we need to do another xy value chart. So I'm going to do -2, -1, 0, 1, 2, 3. Just like we did on the last one. Now if we do that, -2 squared we said was 4, right? 4 divided by 2 is going to wind up being 2. Okay? Now this is very simple math. You should be able to do this. If you need to write it out and do each one of them by hand on the side, by all means be my guest. But all we're doing is plugging these x values into this function to get our y values. Now if I plug this -1 in, -1 squared is +1. +1 times 1/2 is simply 1/2. So we have 1/2 right here. If I plug 0 in, I should simply get 0. If I plug 1 in, I should still get 1/2. Okay. If I plug 2 in, I should get 2 squared is 4. 4 divided by 2, or 4 times 1/2, is 2. If I do 3, 3 squared is 9. 9 times 1/2 is simply 9/2. And we'll leave it as that. Okay. Now, if I go to graph this, means x is -2, y is going to be +2. So there's a point right there. X is -1, y is 1/2. So right about there. Okay. 0, 0, obviously a point. And we've got 1 and 1/2 is another point. And, oops, it's pretty close. 2, 2 is a point. There we go. And 3 and 9/2. Now, if you look at 9/2, it's the same thing as about 4 1/2. So it's going to go right there. And like I said, it's a mirror image here. So if I wanted to put that one, I could as well. And I could find that -3 point. Now all I have to do is connect my dots as best I can. Draw me a little arrow. And I've graphed this by hand. So graphing by hand, hopefully you've done it before. And hopefully you're not finding it too hard. If you wanted to check yourself, you could definitely come over here to y equals. You could do 1/2 x squared. You could do zoom standard. There it is for you. If you wanted to check your table values, you could go second table, and there's all your values. Now they don't have it in fractions, they've got it in decimals, but you can pretty easily use your calculator to make sure your decimals are the same thing as your fractions. Now, number 2 here says f of x equals x over x plus 3. Now, this one might not be as intuitive to do in your head, but we'll do some of them, work them out to the side. Let's work with the same x values though. So we're going to go -2, -1, 0, 1, 2, and 3. Alright, so that if we plug -2 in, we're going to get -2 over -2 plus 3. Okay, so -2 plus 3 is going to give you a 1. You're going to wind up with a -2 over -1. I'm sorry, -2 over 1. So that your answer is just simply a -2. Alright, change color so we can differentiate. So if I plug -1 in, I'm going to get a -1 over -1 plus 3. I wind up with a -1 on top. I wind up with a 2 on the bottom, because 3 plus -1 is 2. So I wind up with a -1/2. Alright, so if I plug in a 0, I get a 0 on top. 0, and I get a 0 here, so I get essentially 0 over 3. 0 over 3, simply just a 0. So hopefully you can see that one without me working out. If you need to write it down, be my guest. If you need to do as much work as you feel like you need to do. Don't feel ashamed if you have to take a few extra steps to figure something out. It's better to take a few extra steps and get it right. Now if I plug 1 in here, I get 1 over 1 plus 3. So it winds up being 1 over 4. So this one's going to be really fun to try to graph, because we've got all these little small things we're going to have to graph on here. Alright, if I plug 2 in, I get a 2 on top. I get 2 plus 3, which is 5. Probably should change colors, sorry about that. I think you can follow me by this point. So what we get is 2 over 5. So 2/5. And if I change number or colors to finish it out, let's go ahead, we'll use purple I guess. Let's do 3 over 3 plus 3. Three over 3 plus 3 should be 3 over 6, which is the same thing as a half. So how about that? Alright, so this last one's a half. So if I go about graphing this, change it all back to black. So if I go -2 and then down 2, should be about right there. If I go -1 and down about a half, should be about right there. 0, 0 here. 1 1/4, making it difficult. 1 2/5, they're not quite a half. And 3 1/2. Notice I'm doing the best I can. Those are not perfect at all. But essentially what we see here is we've got some kind, if I'm sketching it by hand with nothing but this to go by, we have some kind of curve that's going to come through here looking something like that. Now, this is just from the graph points we've done by hand. If I come over here to my TI calculator, I do x over x plus 3. So y equals x divided by x plus 3. You need to put that x plus 3 in parentheses, because if you don't, it won't all be considered on the bottom, and it needs to all be considered on the bottom. So if we graph this, what we notice is we have completely left out a section of the graph on the left-hand side. So we've only graphed this piece. We hadn't really graphed it correct because we've kind of left it floating this way. Turns out it has what we're going to eventually call a vertical asymptote and a horizontal asymptote. So this is the real advantage of having the TI calculator here. You can see, like I said, the full picture. The reason, you know, that this value can't be a certain value is if we look at the domain, and we'll have an actual lecture on domain and range. But if we look at the domain here, if x is -3 here in the denominator, I wind up with a 0 in the denominator, and that's something that can't happen. So what happens is these graphs wind up approaching this -3, but never actually touching it. Once it gets to the -3, this graph stops and this one begins, if that kind of makes sense. And then we'll discuss horizontal asymptotes at a later time as well. But what you can see here is this graph here is not correct. It needs to be adjusted. Now you can go into your calculator and you can go second table, and you can kind of see, one, you see that there's an error at -3 for the reason we discussed. But two, you can see and grab some points and finish the graph of this if you really wanted to correct it. So if I take some of these points, so let's take 4, -4, and -6, 2. So let's see, -4, 4. Oops. -4, 4. -4, 4. Right there. And then we said -6, 2. -6, 2. Let's try to grab at least one more point from this left hand side. So we'll back it out a little bit more. You can try to find a whole number if you can. I'm going to go with -9, 1.5. And kind of go from there, because we're going to run out of space on our graph here if we go any further. So let's do -9, 1.5. -9, 1.5. Just going to put you about right here. And you can kind of see by the picture and kind of emulate it a little bit. It kind of comes up here, and you want to know that you kind of get close to that -3, but you don't really cross it. So now we've matched a little bit on that left hand side of what the calculator's telling us to. Let's see if we can come over here and we can erase this line and this piece. Let's see if we can kind of correct the curvature here. We've got plenty of points. We just need to know that it doesn't really hit this -3, it just kind of approaches it. So if I kind of start down here, I can curve up into my line, and now it might not be perfect, but it's a lot better than what it was, and I can show the full picture. So that looks a whole lot more like what our TI showed us here, if that makes sense. So your TI can be a very useful tool, right? Because if I had to just graph this by hand and I grabbed some random points, one, I just graphed a piece of this line and I didn't have the end behavior perfectly right. Two, without the TI, if I hadn't have looked and seen this x plus 3 on the bottom and known there was a domain issue, I could have actually wound up having a point over here in my list and somehow connected the two and really can't come up with something that was wrong. So you really need to use your TI to your advantage so that you can, confirm what you've done is right. Alright, so number 3 and number 4 here, the instructions say graph the functions with a graphing calculator using a standard viewing window. State whether the graphs have a turning point on this window. So let's do it. We've got y equals x to the third minus 3x squared plus 4. So if we come over here to y equals, we've got x to the third. So we hit x raised to the third. Make sure you click down from that third so you don't get messed up. The other part was minus 3x squared. And then I believe a plus 4. I always like to double triple check myself so that I'm not looking at something that I'm not supposed to be. So make sure you got it typed in right. Now we want to do it on a standard zooming window. So all I'm doing is I hit zoom, I go down here to number 6, which is standard, I hit enter. You can also just hit 6. Now a turning point is exactly what it sounds like. It's where the graph turns. So here I've got a turning point because I was going up and now I'm going down. And here I have another turning point because now I was going down, but here I'm going up. So this graph has 2 turning points on this viewing window. So if I go back to my notes, you can simply say yes if you'd like. So we can say yes, it has 2. Now you could get a little more fancy if you wanted to. You could name these turning points, or you could say what they are, where they're located. To do that, these turning points, this one's a maximum, this one's a minimum. So the easiest way to calculate it, if you weren't sure, this one's actually pretty nifty because it actually winds up touching the graph exactly at a certain point, and here this one does too. But if you weren't sure that it was an exact point, you could do second calc. You could calculate the maximum. Okay, and essentially what you do with this function, if you do second calc and then click max, is wherever that max point is, first you want to go left of it, hit enter, and it gives you a bound. Then you're going to want to go right of it and hit enter, and it gives you another bound, and then you want to kind of find it. And what the calculator does is it says, okay, somewhere between those bounds and somewhere right around your point is this maximum that you speak of. And then it uses a little program to find it. So it tells us we have a maximum at x equals 0, y equals 4. So if I come over here, x equals 0, y equals 4. Let's just put it in blue. Let's go 0, 4. So that's one of my turning points. My other turning point here is a minimum. We can find it as well. So all we have to do for it is literally the same thing. Pretty much we'll do second calc, but instead of max this time we'll do min. We'll bound it to the left and right. So it says left bound, get left of it, hit enter. It says right bound, get right of it, hit enter. And try to get close to it. Now, if you're scared about not getting exactly on it, it doesn't matter. If you notice here, I'm pretty far off to the right. I hit enter, it does find it. Okay, and it tells me my minimum here is 2.000021. I'm not really worried about that. I'm going to say my minimum here is 2. My y value here is 1.36 e to the negative 11. If you know what e to the negative 11 means, it means I need to move my decimal place 11 places to the left. If I move my decimal 11 places to the left, it's essentially 0. Okay, so sometimes it won't be able to get it exact because it uses an estimation program to do this. Here, it's essentially telling you the minimum is 20. So don't think too hard out the box on that. So my other turning point is a 20. And you could label them as min and max if you want to. That's something we'll wind up doing in the future. Now, let's do this other one. So this other function for number 4 is y equals 40 over x squared plus 4. 40 over x plus 4. So 40 divided by, I'm going to throw that parentheses in there, x squared plus 4. If you don't throw that parentheses in there, that x squared plus 4 won't be completely on the bottom. You'll just get the x squared on the bottom, and you'll wind up with something that's wrong. So anyway, here's the graph of this one. What you notice here is I was going up, and now I'm going down. Okay, so it has one turning point. So you want to write that, you can. So yes, it has one. Alright, we can find that point, no problem. Oop, not there, right here. We can go second calc. This one's obviously a maximum. Okay, we'll go left of the peak, right of the peak. Now, you don't really want to get too far from where the peak's at, but, you know, the calculator still does a good job even if you do. I wouldn't bound it way out here and way out here. There's no need. I mean, but there's also no need to get minutely close. Just kind of give yourself some border area and then guess it. Here it's 0, 10. So it's easy enough. I actually wound up being right on it that time. So, I don't know, we'll do this one in this color. 0, 10. So, we have found our turning points. Some are maxes, some are mins. We'll work on that a little bit later. But you should be able to state whether or not it has a turning point. Pretty easy and straightforward. Number 5 says graph the given function with a graphing calculator using the standard viewing window and the specify window. Which window gives the better view of the graph of the function? Alright, so we got negative x squared plus 20x minus 20. So, let's take our calculator, clear the old one out. Negative x squared. Alright, it said negative x squared plus 20x minus 20. Alright, easy enough. If we graph it on a standard zoom, I believe we're already on standard zoom, but it never hurt to be safe. There it is. Almost looks like a straight line. Not a very good graph. Now, like I said before, when I was talking over the zooms, you can hit a few different zooms. You can zoom it out. You can zoom it standard. You can zoom fit. Let's just go ahead and hit the zoom fit here. Just try around and play around with a little bit so you can get used to it. If you notice, okay, I still got my stat plot turned on. It might help if I turn that off with the zoom. So I'm just going back to stat plot and turning that off. I'm going to see if that makes a difference. Okay, obviously if you hit graph, nothing's going to change. But if you hit zoom fit again, same thing as 0, it still really didn't help. So I can tell now that it's more of a curve, but I don't know if anything else happens over here. So it's really not that helpful. If I go back to zoom standard, it's a lot better than zoom standard. Now it asks me, it says to graph it on this window -10 to 20 by -20 to 90. So if I come over here, I hit window -10. That's fine, I'm going to leave it alone. That goes up to 20 on your X. Now your Y min here, it said was -20 to 90. So let's do that. -20 to 90. Okay, I've typed in what they wanted. All I have to do now is hit the graph button. And as you can tell, that is a way better graph. So that helps a lot. Like I said, sometimes they'll give you the window, you just got to know how to type it in. It's pretty simple, pretty straightforward. A lot easier than hitting zoom standard, which doesn't really show you hardly anything. Zoom out, you can continue to zoom out and sometimes get a good picture like that if you want to play around with that. Sometimes zoom fit works a whole lot better. Sometimes we'll use a lot of times we actually do use a combination of the zoom functions to try to get a decent picture. But it's really something you just got to kind of work with and play with and get yourself comfortable with. So I'm just going to show you, like I said, throughout the entire semester, different examples and different approaches to get there. Alright, so which window goes the better view? Obviously this one, right? So definitely the specified window, not the standard. Okay, and that's an underline, that's not a mark out. Hopefully you can see that. Now this next part says complete the table. Okay, well, I've got this function s of t equals 5.2t minus 10.5. Okay, and I've got a 12, 16, 28, and 43. Now I could do all this by hand, no problem, right? I could plug in 12 for this t everywhere place this t's at. We're not necessarily here to work harder, we're here to work smarter. So let's take this function 5.2t minus 10.5. I'm going to go to y equals. I'm going to type 5.2. I'm going to let x be my t here. And I need to subtract that 10.5. Okay. Now, I honestly here, you can graph it if you want to. And you can see what it looks like. There it is on the window we had before. If you want to do a standard zoom, you could do that as well and try it. But if I hit second table, what's going to happen is I'm going to get a lot of these values that I was looking for. And I can scroll down all I want to here and find these values. So it wanted for 12. So at t equals 12 is 51.9. Simple enough. 51.9. Let's do it in a different color. So 51.9. At 16, if I look at my table, it is 72.7. Easy enough. Okay, your handwriting's probably a lot better than mine, especially since I hadn't got my tablet tool yet for my computer. Now we can scroll down to 23. That's pretty easy. 109.1. Well, sorry, it's 28. Sorry. We need to scroll down a little bit further. 28 is 135.1. 135.1. But as you'll notice, scrolling can kind of take a while. So if I'm scrolling all the way down to 43, yeah, it's really not that hard to scroll, but maybe I want a different way to do it. If your graph does show up pretty good and I want to figure out when t is 43, I'm looking at my graph, you can do second calc value, type in x equals 43 and hit enter. Now you're probably going to get this invalid error code. The reason you're getting that is because if you look at your window here, oops, I had to quit first. But if you go back to your window here, your x doesn't go to 43. It can't calculate it unless it's within the screen. So if I want to calculate what x is at 43, my scale's at least got to go to 43. So if I move this to 50, just give it a little buffer room, my y doesn't have to necessarily hit it. So if I come back over here, I hit second calc, value, and I hit x equals 43, I hit enter, it finds my y. My y doesn't have to be in my screen, my x does. So here at 43, my y is 213.1. That's a really easy change to make, especially if you know the x that you're looking for, which you obviously will. So just go in your window. If you're looking for a 43, go out a little past 43. You can go simple to 44. You can do like I did, jump it up to 50 to give yourself a little buffer room. As long as you go past 43, you're fine. I believe even if you go directly to 43, you'll be fine. And you can try that and play around with that if you'd like. So, number 7. It says data for selected years from 2011 and projected to 2023 can be used to show the balance of federal direct student loans Y in billions of dollars is related to the number of years after 2010. X by the function, and it gives you the function Y equals 130.7x plus 699.7. A says graph the function for X values corresponding to 2010 to 2025. It wants you to find the value of y when x is 13, and it says what does this function predict the balance of the federal district or direct student loans will be in 2029. So easy enough, right? So I've got this function y equals 130.7x plus 699.7. Let's just graph that first. So clear your old one out. 130.7x. I believe it was plus 699. Always there to double check. Plus 699.7. So I always double check. Make sure I've got it right. You probably got your notes printed out right next to you or electronically right next to you, so you might not have to do as much back and forth as I do because I'm sharing the screen. But now that I've got this typed in, I'm going to do something really simple. I'm going to go to Zoom Standard. Zoom Standard does a terrible job here. Okay, so if I go to Zoom Fit, which is Zoom 0, it might give me a better picture. But what I'm seeing here in my problem, okay, I've got data selected from 2011 to 2023. We're looking at the number of years after 2010. Okay, so 2011 would be 1 year after 2010. So my data is essentially going from basically 1 up to 23. Or sorry, not even 23. 1 up to 13. So I really here don't need, I might need some after 13 because we're going to extend it to 2025, but I don't need to go crazy far. I don't need to go 100 far. I might need to go 30 far or 20 far, really, because the difference between 2010 and 2025 is just 15. So if I let my x go from 0 to 15 here, then my graph will probably look a little bit better. So 0 to 15. Graph it. Okay, that graph looks a little better. If I come back over here, if you do want to let it go to 20 because you want a little buffer, that's fine too. Now you gotta kind of think on your feet for y. So if x is 0, obviously y is going to be 699.7, and it's going to kind of continue upward. We were able to capture some of it here, but maybe it goes a little far here. So if we wanted to, we could zoom out a little bit. Hit enter, and what it does is it captures basically the whole screen where you're going to need it at this point. It does mess with your x a little bit, which it does sometimes, but you should be okay. Something else you could try to do with Zoom, if you want to play with it a little bit, you can go back here. You can say, okay, I really wanted that min to stay 0, and I wanted that max to stay 15. Okay, if I do that, my graph's here. If you don't like the way that looks, what you can do is you can do Zoom Fit now. And what Zoom Fit will do after you put your bounds in is it'll hold your X bounds or Y bounds if you put your Y bounds in. It'll hold one or the other, and it will adjust the other. So here I put in X bounds. When I do Zoom Fit, what it does is it adjusts my Y bounds to fit on that X value that I put in. So if you come over here to your window, by using Zoom Fit after putting your bounds for your X in, it automatically adjusts your Y so that it can see it within that range. So that's kind of a nifty thing to know and use. I use that a lot. Anyway, so we've graphed it for these corresponding functions from essentially 0, because that's the number of years after 2010. The number of years after 2010 for 2010 is essentially a 0. So essentially we're going from a 0 to a 15. Those are our x values. Something to keep in mind. So we've done A. A is good to go. Now we want to find the value of y when x is 13. So if I come over here, I can use that second calc, and I can do value, type in x is 13, and it's going to find it for me. It's going to say the value is 2,398.8. So 2,398.8. Easy enough. There's the answer to B. C says, what does this function predict the balance of federal direct student loans will be in 2029? Okay, so if we're looking at this, 2029, if I'm looking at my years, I can just subtract that 2010. And what I notice here, if I subtract 2010, that 2029 is 19 years after 2010. So the number that I'm really needing to plug in on my calculator is 19. Now if you notice here, if we're looking at our window, obviously the x max here doesn't go to 19. And in order to calculate it, we've got to make it go to 19. Or you can go over to your table and find it straight out, no problem. If I change this and then hit graph, it's still going to be missing it there, which isn't a big deal. If you really wanted to redo your zoom fit, it'll do it for you, make it perfect. But you can do now, you can do second calc value 19, and it's going to tell you that value, and it's going to show it to you on the graph. So our value here is 3,183. So your answer for this one, 3,100, and we said what? 83. So in 2029, the balance of federal direct student loans should be 3,183, and it's actually in billions of dollars, so it's always a good idea to use your units. So we can write billions here. If you want to write up dollars as well, that's fine. You can put your little dollar sign out front if you want to, and you're good to go. So that should wrap up this lecture. Hopefully it wasn't too hard. Go ahead, jump on the homework, get it done. If you have any questions, let me know. Easy enough. And if you're ready, go on ahead and jump on to chapter 1.3. So otherwise, like I said, I'll see you then in the next lecture.